Hello, this is Jack Jackson. In this video, we're going to continue looking at using a continuous CDF, cumulative density function. We're going to do probability and inverse probability computations from that. In this video, we're going to assume that we're given the formula for the CDF and that we have a graphing calculator. And I'm going to show you how to do this on a TI-84 and a TI-nspire. And essentially what we're basically doing is just taking that formula. A probability problem is essentially given that formula, we put it in the graph, put it into graph, and then we give it an x and it tells us a y, or the other way around, we give it a y and it tells us an x. And so if you remember how to do that on a graphing calculator, basically you've got it. So let's take a look at see how this works. So before, in the previous videos, two videos, we were seeing if we're given the graph of the CDF, then we can find probabilities and inverse probabilities by reading off x and y coordinates of the graph. If we're given a formula for CDF in a graphing calculator, we enter the formula in the graphing window. For example, on the TI-84, that would be like you'd hit y equals and put y1 equals whatever the CDF formula is. And then we use the graph to help us compute probabilities and inverse probabilities. Recall that the y values of a CDF go from 0 to 1, so these are slightly beyond should be the vertical window setting. If you got one of the new fancy color TI-84s, you can actually use 0 to 1 pretty well. But sometimes we want to do some calculations which show up at the bottom of the screen. We don't want it to cover up the graph, so it's useful if we put a little extra space at the bottom so we can start at, say, negative 0.2 for y min. And you can use 1, or I like to use 1.1 for the y max. So I'm going just a little beyond the 0 to 1. But basically 0 to 1 is the interval you need. So you can always, that kind of tells you what you need for your y min and y max automatically when you're graphing a CDF. And when you graph it, you should adjust the x window then so that you can see it starting at 0 on the left and increasing up to 1 on the right. Okay, keep that in mind, and let's look at this example. So here's an example of a CDF function. Now, first of all, we're going to get this in our calculators and graph it and convince ourselves that it really is a CDF function. And then from there, we're going to compute some different probabilities. The probability that x is less than 5, the probability that x is greater than 7, the probability that it's between 4 and 8. And then we're going to compute some inverse probabilities. The probability that x is less than 8 is 0.4, find A. And one to the right, where the probability of x is greater than b is 0.05, find b, and then find the median of the distribution. So those three are inverse probabilities. The first three are probability computations. Okay, so the first thing I want you to do is get this in the calculator. Get this in the calculator and graph it. I already told you what to use for y window, y min and y max. Experiment till you find in x min and x max they're going to make this thing work. Okay, so see if you can do that now. Okay, so here's what we need to do on a TI-84. You type in 1, don't forget, and to divide, don't forget parentheses around the denominator. 1 plus 2 times e to the power, this is here, negative 0.3x, close parentheses on the power, close the denominator. All right, so now what do? We need to graph it, but let's set our window first. So hit window, and we know, first of all, without even messing with it, that the y min is negative 0.2, and the y max is 1.1. We can always use that for that. And in fact, we can go ahead and set the y scale to be 0.1, which is what we have here. Now, I don't know what I need for x min. Let's just start with negative 10 to 10 and just see what happens. We may want to adjust this. So let's just hit graph and see what happens. Well, that's not too bad, although we should see this going all the way up to 1 and leveling off. It's not quite leveled off yet, so we need to go a little further to the right. We're almost to the point where we can't tell it apart from 0 on the left. But maybe we need to go a little further to the left and a little further to the right. So let's go out a little bit more. Looks like we need to maybe go a little further out on the right than the left. So let's maybe go back to our window. And this part's a little guess and check. But let's see How about negative 20 to 25? And let's see what happens there. And we might want to, you can leave it just like that. That's a pretty good window. We can see it leveling off here, leveling off here. That's a pretty good window. If it levels off way in the middle of the screen, you got a whole bunch of long, looks like just a horizontal line, then you could probably come in a little bit. If you don't see it getting up to 1 or down to 0, then you need to expand your window a little sideways. But the vertical part, we kind of know. Now in this case, we could leave it like that. Those marks are kind of close together. So if I wanted to, this is optional, but I could maybe mark it off every 5 or every 2 or something like that. All right, so there's a pretty good graph. Okay, so now we have the graph. Let's do the same thing on the Inspire. So here's the Inspire. The first thing you want to make sure is you come here and that you click on a graph window. I already have one, so I'm just going to go back to my current document. And I want to get over to tab 1.3, which is my actually my graph. So I'm going to calculator screen, control and right arrow will put me to the next tab, which is a spreadsheet. Control, the next tab is my graphing window. Okay, now let's see, I think Control G will pull up where I can enter my formulas. That's kind of like the y equals. Okay, and we type it in pretty much the same way. 1 divided by parentheses for the denominator, 1 plus e to the power is right here. E to the power. Now I put it up in the power, so in this case I don't have to put a parentheses around the power. I could. It's not going to hurt anything. But since it's all up in the power, that's already grouped. And I could go out like that and hit enter. Now notice again, I don't have a really good window. It does put the graph label there on there and it graphs it, but again it's not a very good window. So let's change the window. I can find that under menu and go to window zoom and window settings. And again, Y min we want to be negative. Let's try negative 0.2 again, and Y max to be 1.1 like I suggested on the other one. And we can let it auto scale it. And based on this, what we just already found out on the other one, I can cut to the chase here and say go from, actually I need to make sure I use this, negative 20 to 25. And now it should match the other graph. Something's not quite right. Okay, I'm missing something here. So let's go to Control G and let's go up. Yeah, I'm missing a coefficient here. This should say 2. And it's not 0.03. All right, come on. Got to be able to copy things over correctly. Try again. And it's just 0.3, not 0. Not 0.03. All right, now that's the graph. That's looking like it's supposed to look. So what we should see is y equals 1 right here at this grid line, of this little mark right there. We draw that across. That's your asymptote. And asymptote of the axis there. I'll just leave my label up there. Looks like we got a pretty good graph. All right, now we want to find the probability that x is less than 5. Well, that's just from this graph, we know x is 5. We just want to find the y. So that's pretty easy to do. In fact, there's several different ways we can do it. One way we can do it on the TI-84 is we can hit trace, and we could arrow over, but we want to get it exactly when x is 5, so we just type in 5 like that and hit enter, and it's going to show us the point on the graph, and we know x is 5, and it's going to tell us the y. So the answer we're looking for is right there, 0.69143.845. Notice if we quit and hit x right after doing that, that's the x we came up with, and alpha y is that y value. We can also do it from the home screen. If you hit variables, right arrow to y variables, number 1 function, and then number 1 y1. So let me say that one more time. Variables, right arrow to y variables, number 1 function, number 1 y1. You can get y1, and then it knows function notation, so you can say y1 of 5 like that in parentheses, and it gives you the same thing. Now, that's the way it works on a TI-83 and the older 84s. It works that way on the newer 84s as well. If you've got a newer 84, you can also go alpha trace, which is F4, and Y1 shows up there. So if you got the newer operating system, that's a shortcut to finding Y1. So you can just get Y1 like that and do Y1 of 5. And you can also do a table. Just make sure your table setup is going to have 5 in it. 0 going up by 1s will have 5 in it. And so I can then look at my table, second graph, and go down here and find 5 in the table for the CDF, and then put that cursor on that. Notice it's rounded off here in the table. We have lots and lots of digits here. So there are even more digits, actually, that were even shown at the home screen that you can see there. So that's the TI-84 way of doing it from the graph, the home screen, and the table. Okay, we can do similar things over here on this one, I believe. Let's see. Go to Menu, and then Trace. We can say Trace the graph, and I think I can just type in 5, and it will go to the point right there, kind of puts a little crosshairs on it, and there it is. Now it's not that many decimal places shown, but there it is. Now this is F1 instead of Y1, Y2, etc. They're called F1, F2 over here. Now I can go back to my other tab in a similar way, and I can do it by, I think I can do it, just hit variables, and F1 shows up, and I can say do F1 of 5, and there it comes up.